What's up, guys? In this video, what I want to do is show you how to solve a system of equations when we have 3 different equations. And I'm going to do that by working through 5 different examples that I have hand selected to help you out through the process. I hope you enjoy.
Remember, when dealing with a system of equations with 3 variables, we've learned 3 different processes for solving a system of equations with 2 variables. We learned elimination, substitution, and we also learned graphing. Right? So our main goal is if we can take this system of 3 equations and break it down to a system of 2 equations with 2 variables. All right? So to get it down to 2 equations and 2 variables, what we first need to do is get rid of a variable. And remember, just when we learned the elimination technique, the best variable to get rid of is one that has a coefficient of 1 or negative 1. And so we look at here and we look at where is there a variable that we have a coefficient of 1 or negative 1?
Y.
X, y, and also z, right? Now, I would probably say that the variable with a 1 compared to a negative 1 would probably be the easiest to get rid of. All right? And actually, did I already go over this problem with you guys? Maybe it was the 11. I'm sorry? Right, OK. You're right. So you could so I could get rid of a y very quickly with this one, right? Right. But maybe somebody wants to get rid of x. Did anybody do z? Nobody?
Oh, I did z with the 3 and then the other 3.
OK. Yeah, you could do z with the 3s. I would probably say, even though, yes, you could probably get rid of the 2 y's by adding these 2 equations up, this one might be the easiest to get rid of, the z's, because all I have to do is multiply this second equation by 3, and then I can add it to both of those equations. Does everybody see that? It doesn't really matter which way you guys go, though. You can eliminate the x, the y, or the z. It does not matter. Let's actually go through this one. I'm sorry? You want me to eliminate the x? I actually already recorded one for solving for the x, so I'm not going to solve for the x.
Go for the z.
Let's do the z. That actually sounds like a good one. So the first thing I like to do is label them 1, 2, and 3. All right? So what I'm going to do is I need to pick 2 equations to eliminate the z. So I'm going to eliminate this. I want to eliminate my z variables. So what I'm going to do is I'm going to take equation number 1 and equation number 2. So I have 2x plus y plus 3z equals negative 2. And then I have x minus y minus z equals negative 3. Then I'm going to take equations 2 and 3. So 2 would be x minus y minus z equals negative 3. And equation 3 would be 3x minus 2y plus 3z equals negative 12. Now, does anybody know why I chose equation number 1 and 2 and 2 and 3? Could I have picked different equations? Yeah. It's OK which ones you want to pick. If you guys wanted to do equation 1 and 2 and then do equation 1 and 3, that's fine. If you guys wanted to do 1 and 2 and then 2, or well, you can't do 2 back 1, but if you could do 1 and 2 and then 1 and 3. Or you could do 2 and 3 and then 2 and 1, which we did up there. So it's OK which way you pick it. But the main important thing is we need to eliminate our variable. Now, we chose eliminating variable z. So the easiest way to eliminate variable z is to multiply equation 2 by our multiplier 3. So that's exactly what I'm going to do. I'm going to multiply equation 2, I'll multiply it like this, times 3. And the reason why I'm going to multiply the equation by 3 is because when I multiply 3 times negative z, I now have a negative 3z. All right, so let's actually just write it out what it's going to look like. So I'm going to rewrite equation 1 again. So equation 1 is 2x plus y plus 3z equals negative 2. And then now my new equation 2, which is now going to be 3x minus 3y minus 3z equals, let's see, negative 9. Did everybody say that? So then what we do is we add them by elimination. Since I have a positive and a negative of the same coefficient, I'm going to add them. Here I get 5x minus 2y. This goes to 0, or adds to a 0 as a coefficient. 0 times z is 0. And then this gives me negative 11. So that new equation only has how many variables? 2. So I'm going to label that as A. All right? Then we do the same thing. I use my multiplier, which again, I already know it's equation this number 3x, so I only have to do my math once. So I rewrite equation 2, which is 3x minus 3y minus 3z equals negative 9. And then I rewrite equation 3, which is 3x minus 3y minus 3z equals negative 9. And then equation 3, which is 3x minus 2y plus 3z equals negative 12. And now, when I add up those two equations, I get 3x plus 3x is, let me put it in red again, 6x. This becomes negative 5y. This becomes 0, and that becomes negative 21. And since now, I created another equation with two variables, I'm going to call that equation B. Does everybody follow me? Can everybody see that kind of down there? I'll rewrite them back up here. So equation A was 5x minus 2y equals negative 11. And equation B is 6x minus 5y equals negative 21. So what's the best use of our work here? So now what we can do is do what? Use elimination, substitution, or graphing, right? And probably the easiest method to do for this one would be to use elimination, probably be the best. So to do elimination, I would probably want to multiply. Let's see, you can either eliminate the x or the y's, really. Yeah, y's probably what I'd like to do as well. So let's eliminate the y's. So to do that, I'm going to multiply my a times, let's do by negative 5. So I'll multiply a times a negative 5. So that give me a 5x minus 2y equals a negative 11. I haven't multiplied it through yet. And then b will multiply by a positive 2. So b will multiply by positive 2, so that'll be 6x minus 5y equals negative 21. Okay, so when I multiply those through, my new a is now going to be negative 25x plus 10y equals positive 55. And my new b is now going to be 12x minus 10y minus or equals negative 42. Right? We're using elimination for two variables. Add them up. This gives me negative 13x. That goes to 0. And then this becomes a negative positive 13. Question? No? You good? Does everybody kind of see what I'm doing? Yes, question. All I'm doing is I'm doing elimination. Okay? There's multiple different ways to do it. So your work could be totally different, but you still get the right answer. Okay, it's very possible with a problem like this. It's very easy to mess up. So now I just divide by negative 13. X equals negative 1. So now I know what one answer is, right? So now I plug negative 1 back into one of my equations. All right? So I do 5 times negative 1 minus 2y equals negative 11. And this gives me negative 5 equals negative 5 minus 2y equals negative 11. To kind of ease my work here, I'll add the 5 to the other side to get me negative 6. Divide by negative 2, and I get y equals positive 3. Okay, you guys can do your work on your own. I'm just going to have to kind of move this along. So now I know y equals 3 and x equals negative 1. Well, if I add the 5 over there, I'm going to have negative 2y equals negative 6. So then I divide by that. I'll get a positive 3. And then so the last one, we just need to solve for z. So what I'll do is, it doesn't matter, again, which equation you guys pick. But I know what x is, which is negative 1, plus y, which is 3, plus 3z equals negative 2. So you get negative 2 plus 3 plus 3z equals negative 2. That becomes a negative 1 plus 3z equals negative 2. Add the 1, that's negative 1. Whoa, what did I type in wrong? 2 times x is negative 1. Y is 3. Oh, it's a positive 1, right? Where did I mess? There's something else I get wrong. Where's the negative 2? Where did I type in wrong? Where am I writing in wrong? That's a negative 2, right? Yeah. Right. Is that what you guys are talking about? No, okay, yeah. So there goes a positive 1. So I subtract 1. Right. 3z equals negative 3. Divide by 3. Therefore, z equals negative 1. So, ladies and gentlemen, my final solution is going to be z equals negative 1. Z equals, or x equals negative 1. All right? And again, yes? Huh? Y was y? No, what is y? Y is 3. So ladies and gentlemen, remember the whole purpose of doing a system of 3 equations. The main important thing right now is we need to get this down to 2 equations with 2 variables. All right? The reason why I want to get this down, Zach, to 2 equations with 2 variables is because when I can get it down to 2 equations, 2 variables, what process do we have for solving a system then? Substitution, elimination, graphing, right? There's all those methods that you have, and that's where I would say, looking at your test results, you guys are pretty good at solving 2 equations with 2 variables, right? Yeah. You feel pretty confident with that. So what we need to do is we need to say, can I rewrite this as a system with 2 variables? Okay, Amber, so I need you to be paying attention so you can see that. All right? Now the first thing is, what is the only part of information that you guys need to know? Well, right now I have x, y, z. But I do have my other equation just has negative 2z equals negative 6. So can I find the value of z, right? Remember, a solution is finding the values of all the solutions, x, y, and z. So in this equation, can I find the value of z? Yep. Yeah. So you could say negative 2z equals negative 6. Divide by negative 2. Z equals 3, right? Correct? Yes. Now, if I plug in 3 into z for both of those, do I now have to worry about my z variable? Because I know what the value of z is now, right? So let's do that. So let's do 2x plus 3y minus 3 equals negative 2. And then I have x plus 2y plus 3 times 3 equals 9. So do you guys see what I did? I just took in my value of z and I plugged it in for z. Now, do I have 2 equations with 2 variables? I do, don't I? All right, so we can now write this as 2x plus 3y.
Pardon the interruption. Do you
Yes.
have a Dara Pappas there?
Yes, I do.
Would you send her to the front office for dismissal, please?
OK. Wait a minute. Where's your cheese things going to go?
Yeah, I mean, I can gladly take those off your hands.
Oh, you already had it?
Yeah.
Oh, OK. Is there any more extra food? Okay. No, I wasn't asked about those. Those are very good. I was just saying if Coach Uden had more.
Oh, I don't have to like this.
You have what? Jello things? I might have to take you up on that offer. Okay. Well, since I'm taking up a video, I'm just going to go through this. Yes, I'm definitely going to see you in a second. So let's go through these two equations. So then I solve for them. And my 2, what I get is 2, or sorry. Ladies and gentlemen, I can add over here, add 3, right? So my first equation could be 2x plus 3y equals positive 1. Does everybody see what I did? Then I could take my second equation, which would be x plus 2y plus 9 equals 9. Subtract 9, and I get x plus 2y equals 0. Does everybody follow me? What I did? I plugged in, I figured out what z was, I plugged it in, and then I solved for it, and now I get my 2 equations. Now I have a system of 2 equations and 2 variables. So now I can use what? Elimination, substitution, whatever. So what would be the easiest way to do for right here? To plug in, yeah, I could use that way. That way, please. So I could solve this. I could rewrite number 2 as x equals negative 2y. Actually, Dar, could you hold on one second? I have something to give to you. So I could rewrite 2 as x equals negative 2y. Then I could plug that in. So I could do 2 times negative 2y plus 3y equals 1. Negative 4y plus 3y equals 1. That gives me negative y equals 1. Y equals negative 1. So now I know what y equals negative 1. I know x. I don't know what x equals yet, but I know z equals 3. So to find the value of x, I could take one of these equations, which I'll take this one. So I take 2 times x plus 3 times negative 1 minus z, which is 3. And that equals negative 2. So therefore, I get 2x minus 3 equals negative 2. 2x minus 6 equals negative 2. Add 6. I'm going to get a positive 4. Divide by 2. X equals 2. I just did a lot. I'm going to go ahead and quick out the video. But just to recap real quick, first thing I did was I found the value of z. I plugged the value of z into my 2 other equations. I simplified it, so I got these 2 equations. I then did substitution by rewriting the second equation, so it was solve for x. I plugged in the value of x into my first equation. Then I solved for y. Once I knew the value of y and I knew the value of z, I plugged them into my second equation and found the value of x. Now, I have 3 equations and 3 variables. Did I just find the value of all 3 variables? And I just solved the equation, right? That's how you solve a system, right? So what we have here, ladies, is a 3-variable system. So what we have is 3x minus 2y plus 4z equals 35. Negative 4x plus y minus 5z equals negative 36. And then 5x minus 3y plus 3z equals 31. Notice we have 3 variables and 3 equations. Very important part, all right? So the first step that I told you guys to write down was to eliminate one variable by using 2 pairs of equations, and then to create a system of 2 equations and 2 variables. So what we want to do, ladies and gentlemen, is we want to eliminate a variable. We want to pick a variable that we can eliminate. So just by looking up those variables, but through talking about substitution and elimination, what do you guys would say might be one of the easiest variables to eliminate? The y, right? And the reason y is so important is because this y, I can eliminate this. If I said, let's forget about the third equation, and if I say I just wanted to eliminate y between these 2 equations, all I have to do is multiply by 2, correct? And then if I said I wanted to eliminate y in between the second and third equations, all I have to do is multiply this one by 3. So it's pretty simple. All you have to do is multiply this middle equation by a number, and you can add it to the other equations and eliminate. And that's what you guys are going to want to look for. So when you're looking for picking a variable to eliminate, pick one that has a coefficient of 1. See, if you're going to pick if you wanted to eliminate x, you have to multiply both equations by a factor to eliminate the x's, right? Same thing if I want to eliminate x between these two. You'd have to pick, you have to multiply a factor by both those terms. So what I'm going to do is, let's go ahead and eliminate. We're going to do is set up two systems of equations. So I'm going to do 3x minus 2y plus 4z equals 35. And I'm going to take negative 4x plus y minus 5z equals negative 36. So I'm only going to pick two equations. I'm going to pick the top two, because you want to pick the one that has your variable that you want to eliminate, y, or that one with the coefficient of 1, and then you pick the other variable. Now what I want to do is I want to multiply this by 2. Because, right, remember we want to eliminate these two variables. So therefore I obtain 3x minus 2y plus 4z equals 35. And then when we multiply by 2, I get negative 8x plus 2y minus 10z equals negative 72. Does everybody follow me what I did so far? All I did was I wanted to eliminate. I'm not even talking about the third equation right now. All I did was I took these two, and multiplied this second equation by 2. So when I add them up together, I'm now going to eliminate my y value. So what I do, where's the what? OK. So now I add my two equations, add them up, just like you guys have done before. So therefore, I have negative 5x plus 0y. And 0y is what? 0, right? And then 4z minus 10z is a negative 6z. And then 35 minus negative 72 is going to be a negative 37. OK? So I have this new equation, which, Ricardo, I'm going to say it's just negative 5x minus 6z equals negative 37. And what I'm going to do is I'm going to label this equation equation A. All right? So actually, you know what? Let me kind of tell you a little tip. I always like to label my equations 1, 2, and 3. So I do elimination with equations 1 and 2. When doing elimination with equations 1 and 2, I obtain equation A. Let's write this a little bit nicer, just so you can see it now. So it's negative 5x minus 6z equals negative 37. So that's equation A. Does everybody follow me? OK. So now let's do 2 and 3. So number 2, again, is negative 4x plus y minus 5z equals negative 36. And equation 3 is 5x minus 3y plus 3z equals 31. Now, again, remember, ladies and gentlemen, what we talked about is we want to eliminate the y. So you have to keep on eliminating the y for all the equations. Don't just say, oh, I'm going to eliminate y, then I'm going to eliminate x. We chose this value for y because it's the easiest one to solve for. So now, what do I need to multiply my top equation by? Or you could do the bottom equation, but it's going to be easiest to do the top to get them to be the same. Multiply by a factor of 3. So that's exactly what I do. I should probably put parentheses around that, so you guys see. So now I multiply every single term by 3. And when I do that, I obtain negative 12x plus 3y minus 15z. And 3 times that's going to be 72. It's going to be negative 108. All right. Then I just rewrite my second equation, because I didn't do anything to it. So that's 5x minus 3y plus 3z equals a positive 31. OK. And I'm just going to go back and label these here. This was equation 2 again, and equation 3. OK, so now we add them up. So remember, we did that whole process so we could eliminate the y again. So what I get is a negative 7x. 3y minus 3y is 0y. And then negative 15z plus 12z is going to be negative 12z. And then negative 108 equal or plus 31 is going to be negative 77. Okay, again, you guys notice now I have an equation, two equations now with no variable y. So we're going to label this B. All right? Has everybody found me so far? So now we found A and B. What's so cool about A and B, Wendy? Oh, no. A and B, that's so cool about A and B is, do they have any y's? No. So how many variables do we have? 2. All right? So now let's move on to step 2. So what we did was, let's see if we did step 1 correctly. We eliminated one variable, which was y, by using 2 pairs of equations. We did one pair was 1 and 2. The other pair of equations was 2 and 3. And then we were supposed to create a system of 2 equations, A and B, with only 2 variables. Is that what we have? Perfect, right? So now step 2 says, solve the system of 2 equations to find the values of your 2 variables. So now what I'm going to do is I'm going to write up A and B. So A is negative 5x minus 6z equals negative 37. And B is negative 7x minus 12z equals negative 77. So to do systems of equations for these, I can't add them up, right? You can use elimination or substitution, whatever you want to do. However, I need to get them to be the same variable. So what I'm going to do is I'm going to multiply A times 2. So when I multiply that by 2, I now obtain my new A, which is a negative 10x minus 12z. You know what? Well, here, let's look at this. OK. I multiplied by 2. I got a negative 12z and a negative 12z, right? No, I didn't. Negative 74. OK. But what I'm trying to make sure, that's fine. If you guys want to do negative 12z and a negative 12z, that's fine. Because what do you need to do? Subtract the 2 equations, right? When you have them with the same value and same sign, you subtract them. However, I'm telling you, more mistakes will happen by subtracting than they will by multiplying by a negative to make sure that you have a positive and a negative so you can just add them. So what I'm going to do is I'm actually going to multiply by negative 2. By multiplying by negative 2, I end up with a positive 10x, a positive 12z, and a positive 74. You will make less mistakes when multiplying, so you get a positive and a negative. So let's rewrite B now. B actually it's just going to be exactly the same. OK? So now I add my 2 equations. Right? We're using the elimination technique. I have a positive and a negative, same term, so I add them. If they had the same sign, you could subtract them, as I talked about. So what I get is 3x equals negative 3. Divide by 3. X equals negative 1. Now we got the value of 1, right? Almost there. So how do you find the value of z for this? You plug it back into one of those equations. So it doesn't matter which equation you want to plug it into, but you just need to make sure you plug it in for x. OK? Negative 5 times negative 1 is a positive 5 minus 6z equals negative 37. Subtract 5. Divide by negative 6. So therefore, I get z equals 7. OK, Ricardo? Z equals 7. So now, ladies and gentlemen, I have x equals negative 1 and z equals 7. Did I solve my system of equations of 2 variables? Yes. So let's go down and move to step 3. Step 3 now tells us to substitute the 2 values of your into one of your equations. You have 3 equations to choose. it does not matter which one you want to pick. So let's just go ahead and pick the first one. So we already know what z and x are. So I'm just going to plug in 3 times -1 minus 2y, which I do not know, plus 4 times z, which is 7, equals 35. All right? So we get -3 minus 2y plus 28 equals 35. Combine my like terms. -2y equals 25 equals 35. 25 plus 25, right? Subtract 25 on both sides and divide by 2. So you get 10. So -2y equals 10. Divide by -2. I now have y equal to -5, x equal to -1, and z equal to 7. So there you go, ladies and gentlemen. That is how you solve a system with 3 variables. Isn't it good? Not bad. Question? 28. I don't know. What did I get 28? That's 28. I think I rewrote it. So you're going to subtract 28 on both sides. So oh, yeah, I combined those 2 terms. You're right. I was right. Do you see where I got the 25? I did -3 plus 28. I combined my like terms. We good?
All right, so ladies and gentlemen, as we were talking about before, the main important thing when looking at a system of 3 variables is we need to break it down into 2 equations that only have 2 variables. All right? So in this one, we got a little help because we have one equation that only has 2 variables. So I'm going to immediately label that A. So I'm going to write A over here, which is y minus 5z equals -3. So remember, our main goal is to take our 3 equations, or whatever equations we have, and to write them down to 2 equations. Because when you have a system with only 2 equations and 2 variables, we can use elimination. We can use substitution to solve for our 2 variables. That's something that hopefully should be a little bit easier for you. So now what we're looking at is I have 2 equations, equation 1 and equation 2. And what I want to do is I want to create another equation from these 2 that only has the variables y and z. So what that means is I need to eliminate the x between these 2 equations. So I'm going to use elimination. So I'm going to add them together. Now, if I add them together right now, will I eliminate the x? No, I'll have -x, right? If I was just to add them as is. So what we're going to want to do is we're going to want to multiply them or divide them by a multiplier. There's multiple different ways to do this. The best way I like to do it is get them so I like to multiply them by a multiplier that's going to have a positive and a negative value. So then when I add them, I get 0x, which will cancel out the variable. However, you can divide one by the other. You can get them so they're both positive and then use subtraction. But I like to have a positive and a negative and then to add. So if I have a positive and negative, that means I particularly would like to get a +2 up there, right? So the only way to get a +2 is you have to multiply x by 2. So what I'm going to do is I'm going to take a 2, and I'm going to multiply 2 times the whole front equation. Therefore, my equation now 1 is 2x minus 2y plus 6z equals 6. And then equation 2 is going to remain the same, where I did not change anything with the equation 2. All right. So when I do that, what happens is I add these up, and I end up getting this becomes 0, 0, 0 equals 12. Right? So I get 0 equals 12. And is that possible?
No.
No.
You can't have that. So when we were talking about when we had two equations, what happens when we got something like this? What do we call our solution? No solution, right? We said, oh, there's no solution at all. So the same thing's going to happen if we take our two equations and we end up getting no solution. Well, then we can't have a solution for all equations. Well, you might say, remember, our solution is going to be apart for all three equations. So since we don't have a no solution between these two, our whole equation is just no solution. All right? So there is not a solution for this problem. It's a no solution problem. All right? And that's it. That's all we got to do for that one. So remember, ladies and gentlemen, when doing three variables, right? The main important thing when looking at three variables is we got to get it down to a systems of equations of two variables, right? Do you guys remember when we did that? We did elimination so we could get it down to a system of two variables, which we called equation A and equation B. Do you guys kind of remember that? Equation A and equation B? Yes. OK. So to get to that right now, we need to eliminate one variable. So we just need to pick a variable that we want to eliminate. And usually you always want to pick the variable that has a coefficient of 1 because that's the easiest to manipulate. And if you look at on this third equation, I actually have three different variables with the variable 1. So I really kind of have a great option of which variable I want to eliminate. So does anybody have a variable that they tried that maybe would like me to choose that one?
Why? I hate that one.
OK, well, don't want to be discriminatory against y because y can be your friend.
Why?
So OK, so let's go and eliminate our y. If I want to eliminate the y between the first and the third, let's write out the first and the third equation. So I'm going to do 2x plus 2y plus 2z equals -2. And then over here I have x plus y plus z equals -1. So to eliminate the y, what do I need to do? I need to multiply my second equation by -2, right? If I wanted to add them, I could multiply it by 2 and then subtract them. Or I could also divide the top equation by, could also divide it by -1, right? Or divide by -2. So, but let's just multiply this by -2. Just make things simple. So I'm going to multiply everything times -2. So therefore I get, so let's label our equations 1, 2, 3. So right now I'm using equation 1 and 3. So I do 2x plus 2y plus 2z equals -2. Therefore I get -2x minus 2y minus 2z equals +2. Right? Correct? Then, when I go ahead and solve for this, I get 0 equals 0. OK? Right? When you add these up together? Because now the next step, you're supposed to add these up. Now, we're supposed to get equations from this, but we get 0 equals 0. Now, ladies and gentlemen, remember what we're talking about when we're looking at our systems of three equations. When we have something like this, what does that tell us about our solution? That we're going to have infinite many solutions, right? So let's just go and take a look at equation number 2 and number 3, just to make sure that we're not dealing with two lines that are exactly the same intersecting another line. So we have 2 equals 3, so we do 2x plus 3y plus 2z equals 4. And they have x plus y plus z equals -1. And let's say we want to eliminate y. So to eliminate y on this one, we're going to have to multiply the top equation by -3, right? So therefore, you get 2x plus 3y plus 2z equals 4. And here we get -3x minus 3y plus, or minus 3y times a -3z equals 4. But you get -x, 0y minus z equals 0. I'm just showing you guys another step. That's a positive 3, right? Yeah. Thank you.
Yeah, wouldn't it be 7, not 0?
Yeah. So now, when we do a plus a, we get here, we have infinite many solutions, and here we have, let's solve equation b, negative x minus z equals 7. Now, let's think about this in terms of what possibilities could we do, all right? So we eliminated these two down to 0 equals 0. That always told us that we have infinite many solutions, right? Because there's infinite many things. Now let's look at this. How many possibilities are there for me to take negative x minus z and get 7? How many possible combinations are there? Infinite, right? So this is another way. If you get to this point, you guys can see that's why we get infinite many solutions. Okay? Because when you guys look up there, what you obtain is infinite many solutions. All right? Yeah, you can see. Because think about what are the possibility. It's like me saying, what's x plus y equals 10? How many different combinations are there? Infinite many, right? You can do positive and negative numbers. Okay? So that's where guys are going to have that. Make sense? Okay, so that was that one.